In this lecture, we will see the third program. The two simple programs we have seen in the previous lecture. So let's see third one. So here we have to write the instruction for multiplication operation. They have given some condition. We have to perform 2-bit data multiplication operation. The data should be 2 8-bit data, and we have to access that data from memory location 300H, and another data is 3001H. We have to access the 8-bit data from these two memory locations and perform a multiplication operation. After performing the multiplication operation, we have to store the result into the 3020H memory location, and with respect to 3021 another memory location. So we have performed the operation to write the instruction of followed by this operation. So here the example I have given. Just a minute. Okay, I will take here the example. Here I am assuming here I have to assume the data 909H is present in this particular memory location, and 20H data is present in this particular memory location. First, I want to go at this particular memory location and access these data. After accessing these data, I have to perform multiplication operation. After performing the multiplication operation, whatever the result is there, I should place that result into these two particular memory locations. This is the task. So according to this, we have to write the instruction. This is the flow diagram. So we have to write each instruction. So this flow. So let's see first what we should do. We have to start from getting the first number. So before going to perform multiplication operation, we have to get the data. On what data we are doing operation, we have to get first that data. So here assume this is the memory location. This is the memory location, and these are the memory location. And assume this memory location is 3020H. Okay, and just a minute. Okay, and 3021. See, assume here in this particular memory location, I am having this data, and this particular memory location, I am having this much data. First, I have to visit this particular memory location and access the data and store in other place, and again I have to move into this particular memory location, access the data and store in another register or in an accumulator. Then after accessing these two, I have to perform the multiplication operation. After performing multiplication operation, the whatever the result present, I should place in this particular memory location, these two particular memory location here. Yeah, these two particular memory location they have given. So we have to perform task according to this flow. First, what we have to do, we have to go here. What? At this particular memory location. So I am going at that particular memory location by using move dptr at hash 300h. So what are I am here doing? I am visiting this particular memory location. This is my DPTR. This is my DPTR data pointer. This is my DPTR. I have visited to this memory location. Now I am on the door. After executing this memory location, our DPTR is here. Now move x comma at the DPTR. Move x a comma at the DPTR. So whatever the data inside this DPTR, we have to access into A. A is nothing but accumulator. Here 09H. C at DPTR. Now before DPTR having 300H. 300H at that particular memory location, the data access first and place into the accumulator. Then after, what I am doing, my accumulator need to free for further operation. So now it's busy. Now it's busy with the value of 09. So what I am doing here, I am moving the accumulator value into the register B. Okay. See here, by executing this instruction. So move B comma A. In this type, what I am doing here whatever the value inside A, I am placing into register B. Now our A is free now. So now what I am doing, I am incrementing DPTR. After executing this instruction, my DPTR will incremented by 1 and it will visit here. Now my DPTR is on this particular memory location. They have given here. We have to access the data from these two memory locations. Now I am here this memory location. So now I have to execute this instruction move x a comma at DPTR. Now after executing instruction, whatever the data inside the DPTR, now our DPTR is here at this memory location. So we have to go inside and take this data and store into A. Now our A is having 0 to H. Okay. Now done. One task is done. We have accessed the data. What we have accessed now in our accumulator, I am having 0 to H and my register B, I am having 09H. So now we have access data from these two particular memory location. After that, I have to perform multiplication operation now. See, MULAB. So executing this instruction, what will happen? Multiplication operation will be done by using register A. Register A. This is register A and this is register B. What we have now in our register A and B. In our register A and B. Now, see, and after multiplication operation, the result is itself in register A. The accumulator will store the result after performing any arithmetic and logical operation. We know that. We have studied this while using the accumulator part of block diagram of 8051 architecture. Now move DPTR at 0302H. Now they have given a task, whatever the result we are having, we have to move into this particular memory location. Here, we have to store in this particular memory location here. So what I am doing here, moving the DPTR. First, I am setting DPTR here. Here, this is the okay. Now I am After this, executing this instruction, now my data point is on this particular memory location. See here, move dptr, hash 3020h. This is the immediate value I have stored into the data pointer. By executing this instruction, data pointer will come here, this particular memory location. Then after what will happen? Here move x at dptr, e. Whatever the result, this result will be moved into this particular memory location. So this is our task. Half task will be done. See, we have assumed this data. It will generate only single result. So we have placed here. Then what about next memory location? They have told you have to store the other result into 3021. If instead this we have taken any division operation or anything, we have to keep it in mind. Register B will assist to the accumulator A while doing any arithmetic in multiplication and division operation, and the part of result will be stored into the register B. So here the part of result we have no any part of result we have got, so we have to store 00 here in this memory location. So after that we have to increment our dptr. So after executing inc dptr, our dptr now come here. Now my dptr is come here. So after executing this instruction, dptr will be incremented from this memory location to this memory location. So after that, what we have to store here? Move A, B. So whatever the data or the result present in the register B, we have to move in this memory location. So how we can move the data pointer or the data from register B to this particular memory location? By using this instruction, move A, B. Means whatever the result present in the register B, it will move into the accumulator A. Then move X at dptr, A. Whatever at the memory location the dptr is present on that particular memory location, we are moving the value or data present in the register B to this particular memory location. So presently we are having nothing. It's 00. So 00 is moving in this particular memory location. So this is the task. We have to access these two. What we have did in this programming program, we have accessed the data from these two memory locations and performed multiplication operation. Whatever the result present or occurred after multiplication operation, we have placed these two results in a particular memory location as they have mentioned here. So let's see the next program. So what is our next program? We have to write a assembly language program to move a block of n byte of data. At particular block, the n bytes of data from source to destination. We have to move for the particular block and we have to move the data from one memory location to other memory location. Assume that the length of block is stored in register 2. We have to assume some value at what amount of or what times of data we have to move from source to destination, and that assumed value we have to put into the register 2. And so for what bank of the register we have select, they have given we have to select the register or we have to put the assumed value into the register R2 from bank 0 memory location. So we have to select bank 0 memory location first, then we have to put our assumed value into R2 memory location. Then the other blocks start from memory location 20H and destination block being from memory location 30H. So from where we have to pick the data and what memory location is our source memory location and what memory location is our destination memory location. They have given that 20H is our source memory location. We have to go there first and access the data, and we have to place that data into 30H memory location as they have mentioned in this program. According to this, we have to understand the program, what are the tasks they have given, mentioned. So according to that, we have to perform or to write the instruction here. So first we have to assume some value that will be stored in R2. So R2 is from which register bank? R2 is, it should be from register bank 0. And how we select the register bank 0? We have seen the program status word in previous lectures. The program status word is a 8-bit register, which is a bit addressable register. Each bit we can access and set or clear independently. So the particular memory or particular bit of the program status word, the location 3 and 4. This one is 3 and this one is 4. These two bits of program status word will help to select the register bank. If these two bits are 0, 0, then which bank is going to select? Bank 0 will be going to select. If these two are 0, 1, then bank 1 is going to select. 1, 0, then bank 2 is going to select. Then when 1, then bank 3 is going to select. So we have to clear first these two bits, because after clearing it will become 0, 0. If these two bits are 0, 0, the bank 0 is going to select. So how we should clear and how we should set 0 to these two bits by using this instruction. We have to execute CLR PSW.3. So CLR means clear, program status word dot 3 is nothing but third bit of the program status word is going to clear. Whatever the data present there, it don't take a mind, it will simply put 0 there. Then next instruction is CLR PSW.4. What it will do here, the fourth bit of program status word is going to clear. Now this becomes 0, 0 combination. Now this is a 0, 0 combination, then bank 0 is going to select. So this is our first task is completed now. Then we have to assume our R2 of this bank, R2 of this bank having some value. Let's see, I have assumed 03 decimal values. Then it means the 3 times of the moving the data from source to destination should be performed, because I have assumed the value 3. If I have assumed 4, the same task should be performed for 4 times. Now let's see how the data should be accessed from this particular memory location and how we can place the values. So first I am considering register R0. What I am doing, I am writing instruction like move R0, #20H. So now I am placing #20H immediate value into R0, because at this address of memory location, I should go and access the data. So first I am putting the address into R0 by using immediate value, because we have mentioned here in the program. At this particular memory location, we have to go there. Okay. Then next, after move R1, comma hash 30H. So what here I am doing, where should I place the data? So after accessing this data from this particular memory location, and after I should place this particular memory location. So the address of this particular memory location I am storing into register 1. By using immediate value, I am giving here 30H immediate value. This is the address and I am placing this address into R1. Now what I am doing? Now our data pointer. So now what we are having here? See, move a comma at R0. So move a comma at R0 means load the accumulator with the number from the source bank. Whatever the address is there in R0, R0 having 28. But in this particular memory location, go there and take the data and put into the accumulator. Then what it will do, load the whatever the data in that particular memory location will be loaded into accumulator. Then after loading the data, what we should do, we have to place the data from source to destination. We have visited to source memory location and access the data. Now I have to place the data in destination memory location. Our destination memory location address is placed in here, this register here R1. 30H is placed in R1. At that particular memory location, accumulator will load the data into this particular memory location. So one task is completed here. Then I have to perform this for 3 times because our assumption value R2 is 3. So what I am doing now, I am incrementing R0. We are doing all the operation in same block. Now I am incrementing my R1 and this 20 value will become 21H. Then this, after incrementing R1, this R1 will hold the value 31H. After, what should we do? Same operation I should perform here. Same, now, same. I have to go R0, whatever the address present is there, go to that particular memory location, access the data into A, and again we have to load the data into this particular memory location. The same operation will be performed until what? Until execute this instruction. Satisfy the condition of this instruction. What is this instruction? This is the branch instruction. What is telling? Decrement and jump until what? Non zero R2 value. Decrement and jump until the R2 value should be 0. Here our R2 value is 3. Once operation is done, then increment operation will be carried out. Then after that, decrement R2 by 1. So R2 will decremented. So 3 value decremented by 1 by 2. 1 into 3 minus 1 equal to 2. So R2 now hold the value 2. It will check if R2 is 0 or not. No 0. It will jump only in condition jump, decrement and jump non-zero R2. R2 no 0, then yes, this is no 0. R2 having some value, it will go again to this L1. This L1 is mentioned here. It will go back to this branch. Then it will perform same task. Then after come here and here increment these two value and also decrement R2 once again. After executing, R2 now become 2 minus 1. It will hold R2 value is equal to 1. Then it will not equal to 0. Then it will jump again here. Then again it will execute and perform the same operation. And after that it will come here and it will check the R2 is 0 or not. Now after decrementing, R2 is equal to 0. Okay, R2 is 0. It will not go back. It will execute the next instruction. What is the next instruction is AND. So these operation will be repeat multiple times by using this branch or loop instruction. By using this branch instruction, we have not required to write the same instruction repeatedly. If we have assumed R2 holds the value 3, 3 is nothing but for doing the particular operation for exchanging the data from source to destination, these 5 instructions are required. So we have to write 3 times again and again. So doing this complexity or this, so this type of will be so this is the way of writing the instruction. First understand the what is the program, what we have to write, and understand all the conditions and understand the flow chart, how we go for the flow, go through the flow, and how to execute instructions step by step. So this is the fourth program. So there are many programs, and these 4 programs are part of your lab practice programs. There are many programs, you have go one by one. If any doubt is there, you can contact me. Okay.